Young people, welcome back. BMB in the house. What we got, guys? We got a new chapter. You know it. Chapter 6, lesson 1, and it looks like your learning objective. Determine the number of solutions a system of linear equations has. Second objective, solve systems of linear equations by graphing. So easy enough, guys. Our concept is systems of equations. And a system of equations is two or more equations. In this sense, linear equations. Our skill will be graphing and, of course, identifying. And that sounds good to me. Swap back. Students will be able to graph linear equations. System of linear equations. Let's get her started. Beautiful looking handout, guys. You know how much I love seeing those graphs. But on that top section, already, guys, just so you know, it's a vocabulary thing. I want to say it's found on page 355. There's a key concept chart. Look it up, right? But what you're going to do is use the graph at the right to determine whether each system is consistent or inconsistent, and if it is dependent or independent. And guys, literally, this is objective 1, where in that graph, some of them are crossing, intersecting each other, which tells me they have a solution, one solution. So a consistent graph has one solution, independent and consistent, right? If it's an infinite number of solutions, then it basically would be a graph on top of itself. So you see here, I'm highlighting the first equation of our system of equations, y is equal to x minus 1. You go up that one, you see, go up and down it. And there's the other one right there, right? And the second one, y is equal to negative x plus 1. There's where they intersect, right there, right? So one solution, which means it's consistent and independent. That's it. That's all you got, right? And so you would move on to the next one, and of course I'm gonna use a different highlight. So as you're watching that, I'm gonna keep talking to you because it's just kind of a view and see and understand. So find your x minus y equals negative 4. Find your x plus 4, you know. And again, what's going on with them? Well, one's going down, the other one's going up, whatever you want to say, but they cross at one spot. And yeah, don't use a highlighter to write. Get that out of there. We need to erase that ugly looking C. But it is consistent again, guys. And in addition to be consistent, it is independent. Just that one solution. So you're gonna keep going with this, 3 and 4. Again, recognizing one of the things you can do right now is kind of see with number 3 as we move on to 3. The first one, standard form or slope-y-intercept form. Yay! Standard form for the second equation. Slope-y-intercept form for the first one. So where would I find the first one? Y is equal to x plus 2. Boom, same one, right? It's in blue. It was green earlier. No need to worry. And then, of course, 2x minus 2y is equal to 2. Boom, bang, pow. We gotta get that one too. But notice those two lines are, well, what's happening with them? You see that? Let's take a look, make sure we see it. They do not cross. And since they do not cross, what is that telling me? Inconsistent. So again, guys, this is what we would call vocabulary. And vocabulary. I'm going to be honest, I prefer you learn how to graph the system of equations and then get to understanding consistent and independent and dependent and all that good stuff. But if you can graph them and you can see where they intersect, then you can pick one solution. If it's the same line on top of the first line, meaning the two lines are written different, but they're the same line, that'll be an infinite number of solutions. That will come up throughout this whole chapter. And then lastly, of course, what happened in our last one, they didn't cross at all. I'm sorry, not our last one, our third one, our one in blue there. You'll notice that those two lines do not cross, and they don't cross because they are parallel. Good. All right, guys, I feel good about this first section. And let's get to the meat and potatoes. Let's get those highlights out here, too. All right, so what we got going on? There it is. Looking good. So graph each system and determine the number of solutions that it has. If it has one solution, name it. All right, so again, as I was referring to, it's gonna be 3 scenarios where you have one solution, you have multiple solutions, like an infinite number or no solution. And who knows what's going on? I don't like to graph when it looks like that. So we're going to move the x term to the other side by subtracting 2x from both sides. Then we're going to get y by itself by dividing the negative 2x by negative 1, which gives me a positive 2x. And we're going to divide positive 1 by negative 1, which gives me negative 1. So now I'm feeling better with my linear equation, going from standard form, slope y, intercept form. Got my y-intercept negative 1, bam, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and we're good. You're good. And guys, you will have to be patient as I get my straight edge and connect those dots. First one done. Now, again, it's real important you guys remember the second equation of this system of equation is a single variable, y is equal to negative 3, which in my mind I go, okay, well, there's negative 3, boom, and then there's going to be negative 3 all the way across. So I can see where the two lines intersect, which is telling me it has one solution. Bam, there it is. So tell the number of solutions, telling you exactly what the solution is, negative 1, negative 3, and I guess that's good enough. One solution located at negative 1, negative 3. Box it and drop it. All right, guys, so any questions? Let's move on to number 2. A single variable again, x equals 1. Where's that at? Right there. Boom, and right there. Boom, and right there. Boom, and right there. And there, and there, and there. So everywhere on that vertical line, x is equal to 1. So I'm going to get a vertical line where x is equal to 1. Goes on forever and ever. Second one, again, I just want it to be the way I like it. So do you know the first step to getting y by itself? Good. I'm not showing it, guys. Hopefully, if you need it, I've got some videos further back, but M and B. B and M, I guess. B is 4, M is negative 2. We didn't do this in the first one because I assumed, don't make a scribble out of you or me, but I went ahead and skipped that step, but this time you'll recognize what does it mean. Start at 4, go down 2, and boom, you see that red dot? That's my intersection. Down 2 to the right 1, down 2 to the right 1. And remember, you want to do as many points as possible when using the slope because you can get all those points. We're not using x and y intercepts, so just keep counting to get it. You see where the two lines intersect? Again, that's my one solution located at positive 1, positive 3, I believe. Let me take a look. Positive 1, positive 2. Close enough, right? And again, guys, make sure you recognize where your solution is and go ahead and mark that solution. And I didn't write it out in red, but you guys got to get it. Next two are both written in standard form, which we do not like, but they're easy enough to move over. So we subtract 3x on both sides, and there we go. Y is equal to negative 3x minus 3, with m being negative 3. What's that mean? You're going to go down 3 to the right 1. Where's your b? Right there for you, negative 3. And we can graph that first one, and then we'll work on the second one. Starting at negative 3, and again, I want to use the slope, and until we go down 3 to the right 1. That could be a problem, so let's do the opposite. Up 3, back 1, up 3, back 1. And doing all of that gives me just 3 points on the coordinate plane. But that's all you need. You know, only 2 points are needed to graph a line. We've got 3 points and connect them. You're not done because the system of equations has 2 equations, so we're moving on to number 2. Again, in standard form, which isn't going to stop us, but it will slow us down because it adds an extra step. And this one, like the first one, boom, just got to move the x term. So 3x, go ahead and get that plus y is equal to 3. And now, guys, one step again, subtract 3x on both sides. And of course, what's my m? What's my b? Got it. So you're kind of seeing already that your slopes are the same. But you start in a different location. So there I start. Now remember, 1, 2, 3, over 1. 1, 2, 3, over 1. Now I say over 1, but I want to say to the right. And again, there's 3 points. And get a straight edge And you can already kind of see that these two lines are not going to intersect. And when two lines don't intersect, that means there's no solution. So let's get that written out. And that's it, guys. Now, we did not have the third scenario where we had a line on top of a line, which would have caused us to have what's called infinite number of solutions. But trust me, you got more handout to go. That's going to show up. So let's go ahead and see what we're looking at. There it is. Let's get it. So guys, 3 more. Again, number 8, I feel good about my first equation. The second one, I don't like it. But I do like y equals x plus 2. Quick, what's the slope? Good. What's the y-intercept? Good. If you see it, you got it. Second one, you don't see it as well, so let's work it out. We move the first term, x to the other side, by subtracting 1x from both sides. Showing the second step, dividing by -1. Do it to the left, you're left with just y. And again, -1x divided by 1, and then -2 divided by 1, because you got to do it to both of those terms, right? So there it is, guys. Do you see what I see? They're the same line. They literally look the same. Y equals x plus 2. So you're basically going to have a line on top of a line. So this is what I referred to earlier with infinite number of solutions, meaning that even though there's 2 linear equations, once you graph one, you're going to graph the same one that's right on top of it. So they don't intersect at one spot. They literally intersect at multiple spots on top of each other. Simple concept, but it might take 1 or 2 times to kind of pick it up and get it, right? Number 9, what are we looking at here? X plus 3y equals -3. And x minus 3y is equal to -3. So just like before, guys, I've got two equations, and I'm gonna manipulate both. And when I say manipulate, I'm gonna solve for y. First step, get rid of the x term, it needs to be on the other side. 3y now is equal to -x minus 3. We're gonna divide both sides by 3. Y is gonna equal -1/3 x, and then -3 divided by 3, good. Not 3, but -3. Second equation, same thing. It's in standard form, so we're going to move the x term and then divide by the coefficient of y. The what? Yeah, the number in front of y, coefficient, vocabulary. You know how much I talk about that, guys. So you see it, step 1, x went to the other side. Step 2, divided by -3, and you end up getting what is a little similar but different. Y is equal to 1/3 x plus the 1. So let's graph them, right? Box them and graph them, whatever we're going to do. First point, begin at -1, down 1 to the right 3. See how I went off the grid there? No big deal. Go back to your original point, go up and back 3, up and back 3, and again I go off the grid. But it's okay, because the straight edge is going to show me exactly where these things line up. And there goes my straight edge, and there goes my line. All right, guys, I like it. Now the second one, let's pick a different color because helps, looks good, right? Where are we going to begin for the second equation? We got it. How do we move? Boom, 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 boom. Got it. Boom, 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 boom. Off the grid, no big deal. Go back to my original point, down and back 3, down and back 3. You can see where the 2 lines intersect, so I see my one solution, all right? And with that one solution, finish the line. There we go. Arrows on the edge, all that good stuff. Indicate that there's one solution. And what is that one solution? Looks like x is 0, and my y is going to be -3. Okay, I can count -3. So one solution. Looks good, guys. So we got 10, and I think that's the last one. Let's make sure. Gotta go back and fix that one. Very important, guys, that you understand what's meant by infinite number of solutions. X and y could be anything. X could be 12, and x could be -3. X could be 7, and y could be 9. You have infinite number of solutions for number 8, but for number 9, there's only one solution. X has to be -3, y has to be 0. All right, guys, so number 10. Same thing, this is where we are saying repetition, repetition. Got the x term to the other side. When I added x, it became 1x. I had to get rid of the negative x. So slope y-intercept form. Same thing, just one step, subtract x, and you get y is equal to negative 1x plus 3. So same two questions. What's the m, what's the b? What does that mean? Started at 3, and I like it because it's down to the right, down to the right, down to the right, down to the right. And again, you see all those blue dots, all those blue points. That's because I want as many points on the line as possible. You know, what I'm going to do now is, guys, I didn't even connect them. I just went to the next one. Started at -1, up 1 to the right, up 1 to the right, 1 to the right. Just showing the speed that it can be done with if you really understand the concept. Of course, I already see where the two lines intersect. There's your solution, 2, 1. There's only one solution. And definitely want to connect those lines because that is what you need to do. So with that said though, guys, I think you're getting a good concept. I am going to finish out number 10, but some things we want to revisit. How many solutions can there be when doing system of equations? There can be infinite number of solutions. Or there's one solution, or there's no solution. And later on in the chapter, we'll be doing this algebraically. And we'll be solving, and the solution might be no solution. Or you're going to get something called a true statement, and that's where the infinite number of solutions come from. So with that said, guys, it looks like we're going to keep pushing. Got that solution in. I think we can go ahead and get all of this out of here. Wanted to make sure that you understand the learning objective. Students will be able to graph system of equations. And why do we graph it? So we can find a solution. So, looks like we got 3 more. But I think I'm going to speed through these guys because after doing it 6 times, this is the last 3. So there's 9 problems you have to graph on this handout. And I feel good about you visiting this page, you checking out this video and understanding the concept and the skill. We took x minus y is equal to 3, solve for y, got our first linear equation. Doing the same thing to the second equation, x minus 2y is equal to 3, add x to both sides, gave me negative 2y equals negative 1x plus 3, divide both sides by negative 2. There we go. So you're literally doing a 2-step just to solve for y. That's a skill in itself, guys. That takes it back to chapter 3, I want to say, right? So good job on that. I'll go ahead and box the rewritten linear equations in slope y-intercept form, which gives me m and b, which helps me to graph it correctly. There we go. Started at -1/2. I'm sorry. Started at -1.5. And you kind of see how this time the points are in between because we're dealing with a half, right? But it doesn't change the concept, doesn't change the skills. Just so it's saying start at 2, you gotta start at -2.5. No big deal. The second one, of course, different color always feels good. And again, beginning where it says to begin, now you get a 3. And up 1 to the right one, up 1 to the right one, get all those points. The bottom one, connect your dots. But if you're with me and you've been with me since the beginning, you know the solution. You probably already fast forward to check your answers. And again, guys, anytime you solve an equation, you can check your solution. So the directions did not state check your solution. So we did not go and take the, what is it? Did we finish this one yet? There it is. Looks like we have a solution at 1, -2, and we would plug that in to determine whether or not it's a true statement for both the first equation and the second. That's checking your solution. I'm sure your teacher is going to go over that. 13. Wait, 13. I thought we were on 12. I was like, I skipped 12. So here we go. 13. Y is equal to 2x plus 3. Boom. And then y is equal to 2x minus 3. You guys know where that one came from, right? Well, I'll tell you. I subtracted. I didn't have to subtract. It was already on the other side. You have to divide by 3 with the second equation. And of course, 3y divided by 3 gives you y, and 2x divided by 3 gives you, 6x divided by 3 gives me 2x, and 6 divided by 3, divided by 2. So that should be 2. My editor's gonna get mad if he found a mistake, but he won't see it. He's not that good at He's good at editing, but he's not good at algebra. All right, guys, I can tell we are done. That last one, if you can find my mistake, please comment, let me know, because I see it, and after doing about, what, 13 of these, you're gonna have a mistake somewhere. Guys, thanks for watching. Look forward to seeing you in the next video. We're out.